We'll continue looking at the graphs of our trig functions. And for this first question, we are asked to graph y equals cos 3x between 0 and 360 degrees. State the period of the function compared to the graph of cos, and then we'll do the cos of 1/3 x. We'll actually just discuss that because of what it's going to look like and what our scale along the x-axis will be. But first, we'll graph y equals cosine of 3x. So this is a transformation of y equals cosine x. So we'll start with that as our base function. Remember, cosine starts at the maximum. So it starts at 0, 1. And our critical points are at every 90 degrees. So at 90, we're in the middle. Another 90, we're at a minimum. Back to the middle. And then finish off at the maximum. So this is the graph of y equals cosine x, our base graph. And if we want to do graph equals, or y equals cosine of 3x, we have a b value of positive 3, which remember that causes a horizontal stretch about the y-axis, and remember the stretch factor is the reciprocal. And so, because we're horizontally stretching by a factor of 1/3, the period is going to change. Remember, our period can always be found by taking either 360 or 2 pi radians and dividing it by the absolute value of b. So it'll be 360 divided by 3, which is 120 degrees. So if we start at the point 0, 1, the end of the first cycle will be after 120 degrees. So we'll be back at that maximum point. Another 120, which is 240, we're back at that maximum point. Another 120, which is 360, we are back at that maximum point. If you look at the original graph, halfway between the two maximums, halfway between 0 and 360, looking at the original graph, you're at a minimum, halfway in between. So halfway between these two maximums, which will be at 60 degrees, that's half of 120, we're at our minimum of -1. So we can do that for the other two cycles as well. Halfway between 120 and 240, which is at 180, you're at a minimum. Halfway between 240 and 360, which will be at 300, you're at a minimum. If you look at the original graph, our base graph in blue, halfway between the max and the minimum, you're at a critical point, which is in the middle. So if we go back to our new graph, halfway between the max and the minimum, halfway between 0 and 60 degrees is 30, you'll be in the middle. Halfway between the min and the max, you're in the middle. And we can continue that pattern to plot all our midpoints. So by doing this, we can see that our critical points are every 30 degrees. But we could have got that by remembering that normally our critical points are at every 90 degrees, but they are also affected by our b value. We can get our new critical points by dividing 90 by, again, the absolute value of b. So 90 degrees over 3 is 30 degrees. So we also could have got our critical points that way and then plotted them. In this case, we plotted them first, then went back and saw how we could have got them another way. But either way, we can now sketch the graph of y equals cos 3x. It'll look something like that. And we can compare the two graphs, again using a chart like we did yesterday. So in here we'll have our equations. We'll have our amplitude. We'll have our period, our critical points, as well as our domain and range. And our first equation is our base graph, y equals cosine x. The amplitude of that is 1, the period is 360 degrees, our critical points are at every 90 n degrees, where again n is an element of integers. There are never restrictions on x for these graphs. They go left and right forever, but the range will change depending on the amplitude. For cosine x, it goes between -1 and +1. Right. Then we did cosine 3x. That doesn't change the amplitude. Remember we said that the amplitude is the absolute value of a, the coefficient in front. But now we saw the period did change. It was 120 degrees, and our critical points were every 30 n degrees. So it didn't change the domain. All it changed is how quickly it went through one cycle, but it still goes left and right forever. It also didn't change the range because our amplitude is still 1. Now, for cosine of 1/3 x, the amplitude doesn't change, but our period will change. Remember, our period is 360 degrees divided by b, the absolute value of b actually. So in this case, you're going to divide 360 by 1/3. That's going to give us 1080 degrees. It's the same as multiplying 360 by 3. And that's why we don't really have room to graph it, because our grid only goes up to 360 degrees. We would only be able to graph 1/3 of this graph. Our critical points are also found by taking 90 and dividing it by 1/3, which is the same as multiplying by 3. So that'll be every 270 n degrees. It doesn't change the domain. It doesn't change the range. We horizontally stretch by a factor of 3 in this case. Remember, the horizontal stretch factor is always the reciprocal of b. So we actually horizontal stretch by a factor of 3, which again we don't have room for on our grid. Okay, and then part C above, what is the period for cosine of -3x? Well, it'll be the same as the period for cos 3x, because the period is always found taking either 360 degrees or 2 pi radians and dividing by the absolute value of b. Remember, the negative value of b will just reflect it over the y-axis. The period for here is still 120 degrees. Okay? All right. So now let's put a couple of transformations together. We want to sketch the graph of y equals negative 3 cos 2x for at least one cycle, and we'll state all those characteristics there. But we'll start with our base graph. This is a transformation of y equals cosine x, which starts at positive 1, starts at the maximum, and has critical points every 90 degrees. So this is our base graph. So what's going to happen? Well, our amplitude, remember, is the absolute value of a. In this case, it's the absolute value of negative 3, which is 3. Our period, well, that'll be found by taking 360 or 2 pi radians, and in this case, our scale is in degrees, so we will go 360 degrees divided by the absolute value of b. So it'll be 360 degrees divided by the absolute value of 2, which is 2. That gives us a period of 180 degrees. So, based on those two things, we can start to build our graph. Because the amplitude is 3, we're going to go up to 3 and down to negative 3. However, because the value of a is actually negative 3, that's going to be a vertical stretch by a factor of 3 and a reflection over the x-axis. So the original maximum value of 1, that's a y value, will be multiplied by negative 3, and that's where we start here. So this is negative 1, negative 2, negative 3, positive 1, positive 2, and positive 3. This graph will start at 0, negative 3. And we found that our period was 180 degrees. So at 180 degrees, we're back to that same minimum point. And another 180 degrees, we're back to that same minimum point. Halfway in between the minimum points, you'll be at a maximum point. Halfway between 0 and 180, you'll be at 90 degrees and a maximum value of positive 3. So halfway between 180 and 360, which is at 270, again, we're back at the maximum. Halfway between the min and the max will actually be our first critical point where we're in the middle. That's at 45 degrees. Halfway between the max and the min, you're in the middle. Halfway between the min and the max, which again is 45 degrees from the last critical point, you're in the middle. And same thing here. 45 degrees past 270 is 315 degrees. So this gives us everything we need to sketch our graph. So our max and min values are positive 3 and negative 3 respectively. Our x-intercepts, we can see the first one is at 45 degrees, and the next one is at 135 degrees. They are 90 degrees apart. And then from 135 to 225, again, those are 90 degrees apart. So our x-intercepts are starting at 45 degrees and every multiple of 90 degrees from that. Our y-intercept is at the point 0, negative 3. We're also asked to state the domain and range. Let's do this below here. The domain hasn't changed. It never will for the graph of sine and cos. But our range goes from negative 3 to positive 3 because the amplitude is 3. Okay? So for this one, we want to graph y equals 3 sine 4x. So the amplitude for this would be 3. It's the absolute value of a. Our period will change because we have a b value of 4. Again, our graph is set up so that we're graphing in terms of degrees on the x-axis. So the period will be found by taking the 360 degrees and dividing it by the absolute value of 4, which is every 90 degrees. So we can start to build this graph. But we should start first by graphing y equals sine x. That is our base graph. It starts at 0, 0. It has critical points at every 90 degrees. So the next one is a max, back to the middle, then a minimum, back to the middle. So this is our graph. So because our amplitude is 3, again, that means it's been vertically stretched by a factor of 3. It won't change our starting point because when you vertically stretch 0, which is the y value there, by 3, it won't change. But our period is every 90 degrees. So at 90 degrees, that's the end of the first cycle. Another 90, end of the second, then the third, then the last. Halfway between these two will be where we're back at the middle. If you look at the original graph, halfway between the starting and the ending, halfway between 0 and 360 degrees is 180. You're back in the middle. So halfway between 0 and 90 is 45 degrees. You're back in the middle. Halfway between 90 and 180, which again is another 45 degrees past 90, in the middle. And that pattern continues as well. So these show where our x-intercepts are. Halfway between the first two x-intercepts is where you're at a maximum. And in this case, our maximum would be at positive 3. And the x value there is halfway between 0 and 45, or 22.5 degrees. So our first critical point is our maximum. It's at 22.5 degrees. Then we'll go to the middle. Halfway between the next two x-intercepts will be at our minimum point. Again, that'll be 22.5 degrees past this one here, which is at 45 degrees. So halfway in between these ones, approximately there. Then we're back to the middle. Halfway in between the next two, we're at a maximum. Then we're back to the middle. Halfway between those two, we're at a minimum. Back to the middle. Halfway between, another maximum, back to the middle, halfway in between a minimum, back to the middle, halfway in between we have a maximum, back to the middle, halfway in between we have another minimum, then back to the middle. So you could find where those critical points are by going 90 divided by 4. And that's where that 22.5 also could come from. So this graph is going to be fairly squished together. Okay, so that's what the new graph looks like. So our maximum and minimum values here are positive 3 and negative 3 respectively. Our x-intercepts, maybe we'll write this below just so we have more room. So our first x-intercept is at 0, 0. The next one is at 45 degrees, then 90, then 135, etc. It's every multiple of 45 degrees. So 45 n degrees, where n is an element of integers. Our y-intercept is the point 0, 0. Our domain hasn't changed. It'll always be from negative infinity to positive infinity for the graphs of sine and cos. But our range changed because it's dependent on the amplitude. Okay? So for practice, you could work on page 233 to 234, questions 4, 5, 7, and 8. I will post those solutions to Google Classroom so you can check your answers.